YouTube channel. I am Laxmi Sahu and now I am in class 10th and today I am going to show you the physics chapter first notes, that is electricity. Okay, so guys, if you really like my notes, then please don't forget to hit the bell icon to subscribe my channel and share my channel to all your friends. So let's begin our chapter today, electricity. So electricity term, this is invented by a very famous scientist whose name is Benjamin Franklin. Okay, and electricity has an important place in modern society. Okay, and it is a controllable, convenient form of energy for variety of uses, whether in homes, it may be in schools or in hospitals and industries. And now is electricity is very important because all the work are done by computers, right? And to use the computers, uh, electricity is very important, right? Okay, let's start. So basically electric current and circuit is our topic. So what is electric current, or you can say current, right? So the rate of flow of electric charge, only you have to learn it. The rate of flow of electric charge, that is electrons. So we know that charges are of three types. So protons, electrons and neutron, and we know that protons carry positive charge and electron carry negative charge and neutrons are neutrals, right? So here the rate of flow of electric charge, that is electrons, is known as electric current or current, right? And a continuous closed path of an electric current is called an electric circuit. So for electric circuit, these are some some materials which is used to create an electric circuit are the bulb, basically battery, and a battery is the collection of cells, right? Okay, so bulb, battery, and of course a switch or key, and a wire, right? It can be copper wire, aluminum wire, etc., right? Okay, so there are two types of current, that is conventional current and the electric current, right? So we know that electric current are the rate of flow of charges, that is electrons, right? And in electric current, the electrons, right? So in electric current, there is a flow of charges from negative to positive direction, right? So electrons to protons. But in conventional current, right, in conventional current what is given is, it is opposite, right? It is opposite. That means in conventional the current flows from positive to negative direction, right? So this is the differences between the electric current and conventional current. In conventional current, the current flow from positive to negative direction, whereas in electric current the current flows from negative to positive direction. Okay, so I think this is clear to you all, and here is the formula given. So q I is equal to q upon t, this is the formula, and where I is represent ampere, I represent current, and q represent charge, and t represent time. Okay, and then if a net charge q flows across any cross section of a conductor in time t, then the current I through the cross section is I is equal to q upon t. So we have known that I is represent current. So the SI unit of current is ampere, and the SI unit of charge is coulomb, and the SI unit of time is, we know, that second. So here it is one of the basic formula, that is q is equal to Ne, and q is we know that q means charge, and the charge is equal to Ne, means number of electrons. So this is the formula also. And note that one electron has a charge of 1.6 into 10 raised to the power minus 19 coulomb. So we have studied in our previous classes in class 9 that electron's charge is 1.6 into 10 raised to the power minus 19 coulomb. So the number of electrons constitute 1 coulomb of charge. So when you put the formula Q is equal to Ne, so Q is equal to Ne, when you solve this you will get the 1 coulomb charge is 6.25 into 10 raised to the power 18 electrons. Okay, then 1 ampere, what is 1 ampere? So 1 ampere of current represents the flow of 1 coulomb of charge per second, right? That is 1 A is equal to 1 C upon 1 S. Okay, and this is very important. An instrument which is used to measure current or electric current in a circuit is called as ammeter, and it is denoted by the capital letter A. Okay, then electric potential, and what is electric potential and electric potential and potential difference. Okay, so the electrons in a line flows from one end to the other wire only if there is a difference in electric potential. So basically just imagine that there is 2 points, one point is A and the second one is B, right? So when electric current flows, the difference, right, the difference between 2 points, okay, so the difference between 2 points is called as potential difference. Okay, so the potential difference between any 2 points is defined as the amount of work done in moving a unit charge from one point to another. So this is the formula, V is equal to W upon Q, where V is our potential difference, W is work done, and Q is charge. Okay, then the SI unit of electric potential difference is volt. So SI unit of electric potential difference is volt, and this was discovered by a scientist whose name was Volt. I don't know what is the full name, but yeah, it is discovered by Volt. Then 1 volt is described as 1 volt is the potential difference between two objects when 1 joule of work is done to move 1 coulomb of charge from one point to another. That is 1 V is equal to 1 joule upon 1 coulomb, and we know that joule is the SI unit of work. Okay, then an instrument which is used to measure potential difference is voltmeter, and it is denoted by the capital letter V. So here are the some symbols of commonly components which is used in our circuit to flow the current. So in an electric cells is represented by like this, so you can just see this. Okay, then we have Ohm's law, and it is very very important law and often asked in the exams, right? So Ohm's law is basically defined, or it's give that the potential difference V across the ends of a given metallic wire in our electric circuit is directly proportional to the current flowing through it, and provided its temperature remains the same. This is called as Ohm's law. And one definition is that Ohm's law gives the relationship between the potential difference and current, right, where potential difference and current, right, so where potential difference is directly proportional to current and potential difference is inversely proportional to the resistance. Okay, so this is the definition, or you can also write it like this. Okay, so this is the formula, V is directly proportional to I, or you can also say that I is directly proportional to V. And to remove the proportionality sign, we must have a constant, right? So here when we put constant, and this constant is called as resistance, so resistance is represented by the R, so V is equal to I into R. So this is the Ohm's law. Okay, Then resistance. What is resistance? Resistance is the property of conductor due to which it resists the flow of electric charge. Basically, resistance is opposing, right? Opposing the current. When current flows, it opposes the current, right? So it is oppose the current, and the SI unit of resistance is ohm, right? And 1 ohm is described as you can see. Then current through a resistor is inversely proportional to its resistance, that is I is inversely proportional to I 1 upon R, right? So we have seen the Ohm's law, and in Ohm's law we get V is equal to I R, right? I into R. So when we write I in the place of V, then I is equal to V upon R, right? Okay. So if resistance is double, then the current gets half. We know that, and I have already told you that what is direct proportional and inversely proportional, right? So directly proportional means to say when one gets double, then other will be gets also double, and when one gets half, then other gets double, right? So this is the difference between. So if resistance is double, then the current gets half because I is inversely proportional to R. And component is our instrument which is used to regulate current changing without the voltage source is called as variable resistance or rheostat, right? So this is the rheostat, and it is represented by the letter P, like P, but this is not as P. Okay. Then oh sorry, this is not represented by V, this is represented by ohms like, right? Okay. Then a conductor having some appreciable resistance is called a resistor, and we have already discussed about the resistance. Then factors on which resistance depend. So resistance are depend upon the three main factors, that is its length, its cross area section, and then nature of its material. Okay. So first is R is directly proportional to L. Basically, when length is larger, then the resistance will be also large, right? Or when the length is large, then the resistance will also increase, right? So this is R is directly proportional to L, whereas it is inversely proportional to A. That is, if area is large, the current flow or the electron flow will not get collapse to each other, right? So collapse to each other, and there is no work, or when the electrons get not collapse, then this does not oppose the electrons, or this does not oppose the current. So if area is large, then the resistance will be half, or resistance will be decreased, right? So this is how it is inversely proportional. And then we have required some materials. So it is R is equal to P L upon A. So basically we have to use so to remove the proportionality, we have a constant, and here is constant is resistivity. This is also called as specific resistance, and it is represented by P, right? And this is called as rho. So R is equal to R is equal to rho into L upon A, or when we send the P like in left hand side, then P is equal to R into A upon L. So don't worry guys, I will be upload a video on how can we derive the formula, because this is very easy, and now I can't able to describe this, right? So I will be describe in the very first and our second video, right? So you will get the some tips that how can we also derive the formula. Okay. So resistivity is the characteristic property of the material by which it is resist the amount of current flowing through it. So this resistivity is a natural resistance, you can also say that, which is also oppose the current, right? Okay, then what is given, okay, so the SI unit of resistivity is ohm meter. Metals and alloys have low resistivity, whereas rubber and glass have high resistivity. Okay, then both resistance and resistivity of potential difference vary with temperature. Okay, then resistance of a system of resistors. So basically there are two ways of joining the resistors together, which is resistance in series and resistors in parallel, or you can also say that series combination and parallel combination, right? So in a series, all the appliances or all the appliances are connected to each other in a line in the ends of the other, right? This is called as series. In series, so when one appliance get damaged, then all the appliances get also damaged, or they would not be able to work properly, right? So this is how can you draw this, and this is very important. It is always given in the exams that how can we derive the formula of series combination, right? So you can just see, I will be tell you, or I will be told you in our second video, how can we derive the formula. Okay, so you can just see. And resistors in parallel, so parallel means the combination is occur in parallelly, right? So one there is a separate key or separate switch for all the appliances, so that one appliance get damaged, then the other will work properly, they will not be affected, right? So here is also a formula that how can we derive it. Then disadvantage of series combination over parallel combination. So there is a very disadvantage of series combination, that is, first one is we can't connect different electric component in series, because different components needs different currents, right? And in series combination, if one component of the currents fail, then the circuit is broken and none of the components work, right? Which I have already told you. Then total resistance in parallel circuit is decreased. This is helpful when each gadget has different resistance and requires different current to operate properly. Okay, then our topic is heating effect of electric current. So in an electric circuit, the source, that is battery, has to keep expending its energy in maintain the current consumed in useful work, and rest of energy may be expended in heat to raise the temperature of gadget. So what is heating effect of electric currents? So this definition is, when an electric current passes through a conductor, when the conductor becomes hot after some time and produce heat, this is called as heating effect of electric current. And you may also see in the bulb, right? In the bulb, when electric current flows, the filament gets hot, right? The filament gets hot, and this is also called as heating effect of electric current. For example, an electric fan becomes warm. This effect is utilized in devices such as electric heater and electric iron. So this is the also formula. How can we derive it? I will be told you in the second video. Okay. Then our Joule's law of heating, what is it? It states that when a current, that is I, passes through a conductor of resistance, that is R, for time t, when the heat developed in the conductor is equal to the product of square of current, the resistance, and the time, that is H is equal to I square into R into T, where H is directly proportional to the square of current or the square of I, and H is also directly proportional to the resistance, and H is also directly proportional to T. Then applications of heating effect of current. Then our topic is electric bulb. So it is a device in which electric heating is used to produce light, right? Our filament gets hot, and this shows, or this give lights us, right? Strong metals with high melting points, tungsten is used for making bulbs, bulb filament, right? And some chemical inactive gases, such as in our bulbs, the gases are present inside the bulb are nitrogen and argon. This is very important. and it is also filled to prolong the life of filament, right? And the electric fuse, protects the circuit and appliances by stopping the flow of any unduly high electric current, and it is connected in series with device. So if the current is very large, the temperature of fuse wire increases, and this melts the fuse wire and breaks the circuit, right? Okay, electric power, the rate of which electric energy distributed or consumed in our electric circuit is known as the electric power, right? Okay, then here is the three formula for this. First formula is P is equal to V into I. Second formula is P is equal to I square into R, and third one is P is equal to V square upon R, and the SI unit of electric power is watt. Okay, then 1 watt is the power consumed by a device that carries 1 ampere of current when operated at the potential difference of 1 V. The unit watt is very small, therefore in actual practice we use a much larger unit, that is kilowatt. Okay, then okay guys, so I have completed these notes. So if you like my notes, then you can write from here, and please don't forget to hit the bell icon to subscribe my channel and share my channel to all your friends. Till there, take care, bye bye, see you.